Starting the stream. Starting to record. Yeah. YouTube. Okay. All right. How's everyone doing? We're back. We're actually learning stuff again. We're not just working on projects anymore. I mean, you're probably learning a lot doing that anyway. But I'm teaching you stuff, and Daniel will be teaching you stuff again, which, you know, is bittersweet, right? It was kind of a nice couple weeks off. But either way, we're going to start talking about Node today, which is pretty cool. I'm excited about that because it means I don't have to do anything in the browser for a while, and that just sucks. Who wants to do that? So projects. People feeling pretty good about them? How's everyone feeling about those projects? Especially the Tuesday, Thursday class. I don't know how you guys did. I didn't hear much about it, so feeling okay? Yeah, it went okay? Yeah? Definitely different working in groups like that. Definitely a learning experience, right? Does anyone want to share anything about their experience with everyone else from either class about how it went, or anything cool you guys did, or any problems you might have had, or anything? No? GitHub's a pain? Yeah? It can be, certainly. Until we're really experts at Git, it can be a real pain. Merge conflicts, those seem to come up a lot. A lot of people had merge conflicts and had trouble with those, and that's to be expected. In the beginning, they're pretty intimidating. Once you figure out what they are, they're not so bad, but they're definitely weird because you have all these crazy symbols, and in like VS Code, it like highlights a bunch of random stuff, and you're like, ah, what's going on? You know, so it's pretty nuts. But overall, I think everyone in our class did really great. I'm imagining Tuesday, Thursday was the same. Everyone did awesome. It was a ton of fun for us. I really enjoyed what our students showed us. Everyone did fantastic. We should certainly be proud with what everyone's done. I know we had great quality work. Great quality work. It was fantastic. Like, some of the stuff people did, would not have expected, to be completely honest. And I had a lot of confidence in them, and they went above and beyond that anyway, and it was very surprising. So it's awesome. So yeah, you should definitely be proud with that. I think everyone did a great job. We've got a really good feel of the UI now, I feel like, right? Everyone's got a good understanding of HTML, some of the basics of JavaScript, jQuery, how that all works, I would imagine. We're at that point. And that's why we're going to transition into the server-side stuff. So your projects were great. You should definitely be proud of them. And think about how far you've come so far. I'm skipping this because it's just the stuff Trilogy made that's, you know, I'm not going to read canned stuff about how awesome you guys did. It just feels, you know, not very genuine, right? Anyway, think about where we've come so far. I know we've got a long way to go, but think about when we started, a lot of you were like, well, what's HTML? What exactly is it? Or, you know, hey, what's a div? Or what's JavaScript? Or what's jQuery? What is all this stuff? It's so confusing. And now we're seeing people who can pretty much write production level UIs and stuff with HTML, CSS, and JavaScript, which is really cool, and you should be really proud of that. So we had a lot of fun. It was a great time. I hope Tuesday, Thursday had a lot of fun too. And our next project will be fun as well, but that one's not for a while. So anyway, let's start talking about Node. Does anyone have anything they want to add about the projects or anything before we move on? Just so I'm not, you know, skipping over anyone who had something that they wanted to contribute. Nope. Cool. You guys are a quiet bunch. Every time I ask a question, no one says anything. Anyway, the mystery of the back end. So we've worked a lot with the front end. We're all pretty familiar with the front end at this point. But now we're going to go into the back end. And we have some experience with it. So we've used Ajax to do API calls, right? And we're communicating with this mysterious back end at that point, right? So that's like our first indication that there's something else out there, right? We're not alone. And that was when we started talking with the backend, but we didn't really know what it looked like, what it was, what it did, and we're going to start getting into that. Firebase was our next adventure into the backend, and it's effectively a server. It's more like a database, but anything that's not, on your client is a server, really. And so that was our backend for these projects, for a lot of activities we did, was that Firebase stuff. So technically, you're full stack developers at this point, right? Because you've done UI and you've done Firebase, so you can build full applications. And there's lots of people who actually do that. They'll build their UI, just traditional HTML, JavaScript, CSS, or maybe they'll do like a mobile front end, and their server will only be Firebase, right? Because you can get away with that. It notifies people when there's changes. It does a whole bunch of stuff for you. Anyone can get to it from any device as long as you got the right keys, right? So you can build an entire application suite with just Firebase and some UI stuff. All of you could do that. If you have an idea for an app you want to make or something, start it now. And then slowly, as you find out you need more functionality, and we get better with Node and other backend stuff, replace Firebase with a traditional backend, right? If you need it, you might not. But we're full stack developers now, so you have that going for you. So that's pretty good, right? All right, so let's talk a little bit about the backend. This is pretty important, what we're going to start talking about. So I hate slides. I complain to my class all the time about how they suck. But there's some good diagrams in here that I do want to talk about. It's nice to have the visuals. Even though I think the slides overall, the content on them is blah, whatever. I don't really care. So the MERN stack is what we're doing in this course, right? So the M is Mongo, E is Express, which is something that works with Node. R is React, which is what we'll end up doing our final UIs in, and N is the Node, which we're going to start talking about today. So we're just touching on the N in the MERN stack now, which is pretty crazy, right? We've gone through a third of the course. We haven't even begun with the MERN stack. And that's really what this course is about, but it just goes to show how much there is to learn before you get there, right? But we've done it. So, full stack development, what is it? It's this. It's this MERN stack, or it's what you already did for your projects, or it's anything that effectively has a front end, right? That is some client that your users would use directly, and a back end, which can be, that's a pretty ambiguous term. It can be a lot of things. So this is that model of full stack development that we've seen before. And it's got this user, this little computer here. You can imagine that's, one of us. It's me right now on this laptop working with these slides. And then you have your client, which is my computer, or it's your mobile phone, or it's a tablet, or it's just your browser, depending on how you view the client. And your client can be made up of a bunch of stuff, right? So what we're familiar with right now, the HTML, CSS, the JavaScript, some JSON, XML payloads or something like that, and the user interactions and the stuff that happens, right? React encompasses all of those, which is really nice. So when we get to it, a lot of this work we do is very manual and tedious, is done for us. So that's really nice. And then the back end, which is some server, Firebase, a Node.js server, an Express web server, whatever, what say you. And then there's some transfer in between the client and the server, right? So we've seen HTML. So HTTP requests to return HTML. Those are your HTTP GET requests with the content type of text HTML. And then there's other ones. We've seen JSON, right? We've all seen that now. So that's application JSON content type with a GET request most likely. There's other ones too. There's XML. There's your JavaScript files. Those are also HTTP requests that return text content, a file. CSS comes through an HTTP request is another part of your transfer, right? So full stack development is having this client and this server that are decoupled. They're not in the same application. And when you're a full stack developer, you work on both. You don't just work on the front end or the back end. It's nice because you can choose to work on one or the other, or if your business has a really complicated front end or really complicated back end, they might assign you to one or the other. And there's different skills associated with each one. Obviously, if you're on the front end, you have to care a lot about how the user uses your application, what that experience is like, kind of how it feels to be a user. On the back end, you don't really care about that. You care about the most efficient way to get data from A to B, really, is all it is. Or encompassing some sort of logic to make sure that your data that you're getting from the UI is properly formatted, does what it needs to do, and affects the system in a way that's logical and consistent with your business rules, right? So that's full stack development. That's what we're really getting into right now, and it's pretty cool. So YouTube, YouTube's a good example of a full stack, right? So we have the YouTube webpage where you can type some stuff into that search bar, brings up some videos. When you go to click on a video, the video doesn't just exist in your client, right? There's some streaming protocol that happens behind the scenes that sends the bits that are in the video to your client. Your client knows how to render them somehow, right? So there's a lot going on there. You can imagine, I'm sure, that YouTube is very complex, and it is. I obviously don't know the exact architecture of it because I don't work at YouTube for Google, but it's complicated, right? There's a lot going on there, and it's more than just this client. As a matter of fact, the client's probably the smallest part. There's probably hundreds and thousands of servers behind there that are servicing the entirety of YouTube. So what are some examples of server-side code? Some sort of API that could take your URLs and return JSON. Firebase is server-side, and Firebase methods that can, create timestamps or generate data to get back to the user. Say you have a server that creates a PDF or something, and you click on a button that goes back to the server and gets a PDF. That's some server-side code generating that PDF. Image processing is generally something that happens on the server. And then, Google searches. You go to search. That search doesn't just happen in the client, right? It goes out to the Google servers, finds the appropriate matches with their match algorithm, and brings you back a bunch of stuff. So server-side code is everywhere, and honestly, there's more of it than there is client-side code. So knowing it and knowing it pretty well are good. Very important. So what is a server? So the term server is interchangeable with a bunch of different things, and you should understand that now. The traditional word server refers to a physical machine, right? So a big tower somewhere or a rack in some data center that has an actual computer on it, an actual CPU, processor, all that stuff, RAM, hard drive, and it's an actual machine called a server. Now, when we talk about server, that's not what we're talking about. When I talk about server, I'm talking about some form of an application not on your client machine. Okay? So it's an application is what a server is. Web server is a better way to put it. And then in terms of the web server space, there's different layers to that. There's your web server, which could be something like Nginx or Apache or IIS. And then there's your web server application, which is like a node application that's reverse proxied through the actual web server. So there's a lot of terms and there's a lot of understanding of how this stuff all works. But just know, for the most part, when we are talking about a server in this class, it's a web server application like Node. And what does a web server do? It just takes client requests, gives something back. So I've got a client, say my client's the browser, I type something into the URL, right? Or into the address bar, some URL. It's going to go to the web server associated with that URL. It's going to take the URL, parse it, kind of figure out what it's got to do, and it's going to return some stuff back. Whether that's a text blob of HTML, or it's some JSON, or XML, or pure binary, I don't know, but it doesn't matter. But that's what a server does. It can be anything. So here's a nice little diagram of like what a server looks like. So this is a traditional server, right, with a machine. And granted, while I say a server is just an application for us, it's still hosted on a server somewhere, right? So your server code doesn't just exist in the ether. I mean, if you view the cloud that way, then I guess it does, but that's not what the cloud is. Our code still exists on a traditional server somewhere, somehow, but we don't really care about the hardware. But this is kind of a simple model of how it would look, right? You got your web browser, sends information to the server, server sends stuff back. Pretty cut and dry. Especially because we've seen APIs and stuff like that. We've seen AJAX calls, so we've kind of been able to visualize this and see it in action. So a web client, what's that? A web client lets the user request something to the server and then shows a result from the server, right? So in HTTP, which we're going to get pretty familiar with very, very soon, there's this like two stages of an entire HTTP request process, right? There's the request, which is what the client sends to the server. I'm requesting some resource. And there's the response, which is when the server says, I am responding to your request, right? That's literally what they're called, an HTTP request and an HTTP response. A request goes in, a response comes out when we're looking at the server. And that's really all a web client does, is send these requests to the server and waits for a response. That's it. Sometimes it doesn't even do that. Sometimes it's just like send a request, and if nothing happens, I don't really care. But generally speaking, we wait for a response. Very traditional, easy request response. I go to www.google.com. That routes to the IP address of Google's web server, whatever one that you're going to route to in your region or whatever. And it says, hey, Google, I went to the main page, the index.html. Just give me that HTML. And the server's like, cool, here you go. Sends it back to the response. And your browser's like, oh, great, I have CSS, HTML, JavaScript. I'm just going to render it all, blah, 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 do my thing. And you get google.com, right? And that's kind of all there is to it. I know I'm trivializing it a bit because it's not that simple. Oh, that's all there is to it. Writing the code's not that simple. But the actual model of how the data flows isn't that complicated for this kind of a setup. So here's a little diagram of a web client, right? So a little user here is like, hey, I'm going to go to Google. They do something, click a button, whatever. They go tell the server. Server does a bunch of processing work, gathers a bunch of documents, sends it right on back to the computer, and the user's like, wow, awesome, that worked, great. Okay, so take about 5 minutes and talk to people around you and try to explain all of these concepts that we just went over again, right? We want to hammer this home because you need to understand them. Why you need to understand? You need to understand the terminology because I'm going to use it, Daniel's going to use it, your TAs are going to use it, and we're not going to stop for you to understand what one we're talking about, right? So you need to understand what this terminology means in this class and be very comfortable with it. So spend just a couple minutes talking about that. Okay, Fist 5, how do we feel about these definitions? Feel okay? Yeah, questions? No? We feel okay? Okay. If everyone's feeling good, then we'll go ahead and we're going to move on. Like I said, be familiar with these terms, know what they mean. We're going to be using them a lot for the rest of the class, and so there shouldn't be much thinking when I say, hey, you need to have a, your request is bad, right? You should know exactly what I'm talking about. So, anyway, let's move on. Let's talk a little bit about Node. So that's really important. It is important that you understand this stuff, like I said. Just make sure it's ingrained in your mind. And the intuition about how this web flow works is only going to grow as we go further and further into the class. Because you're going to start seeing it more and more. Especially as we build our first websites that have our own Node backend and our own client, right? That'll be really cool. So what is Node.js? Node.js is pretty sweet. Basically, one day in like 2008 or 2009, this dude named Ryan Dahl's like, hey, I like JavaScript. It's good enough, I guess. I want to run it from the server. And so he wrote this really weird thing that interoped with the Chrome V8 engine. So Chrome has this engine called V8 that it uses in Chrome to render JavaScript. And it just so happens to be open source. Wow, that's cool. Chromium and all that stuff, right? So he decided to take it and said, well, I'm just going to change it a little bit so it works on a machine. And then we can just use it from an application, right? We don't need the browser anymore. And he did that. And there's debate whether or not it was a good idea. But we're here today, so what can I say? Node.js is open source, cross-platform JavaScript runtime environment designed to be run outside of browsers. It's a general utility that can be used for a variety of purposes. Most notably, it is used for web servers, the basis of a web server, right? Generally speaking, that's what we're using Node for, is some form of a web server. Sometimes it's used in command line utilities, and that is growing a lot because it's such an easy thing to use, JavaScript, right? In terms of how easy it is to get into the language and just start hammering away at it, right? There's not a lot of restrictions with JavaScript, so you can write code very, very quickly and very, very iteratively. So it's kind of nice as a scripting language. So what I want you to do is take a couple of minutes and kind of research a couple companies that use Node.js in production. It will not be hard to find 5 of them. This is it? There you go. I told you it wouldn't be hard. All right, as you find some, start yelling them out. Netflix, NASA, Uber, Trello, Uber, Amazon, LinkedIn, Medium, eBay. Okay, so let's be honest here. I'll stop you all. Pretty much everyone who does anything on the web uses Node now. That's just a fact. Because Node is very, very easy to use in terms of a web server. It's extraordinarily powerful. It's pretty performant, and it's very easy to get into. And you get this idea of having isomorphic code. So the definition of that is like I have code on the server and the front end that is effectively the same. It's written in the same language. It could use the same shared code because maybe you have similar models, or right? So there's a lot of benefit to that as well. Node it has exploded in popularity, and to be frank, if you do any web development today and you're not at least somewhat familiar with Node and done something with Node, there's a problem. You are doing something wrong. Because Node is extraordinarily powerful. Now, is it the best for everything? No, but nothing is. So, learning it, though, right now in this class, I think there isn't a better technology for web servers that we could teach you. Really, there isn't. It's that powerful. And there's a lot you can do with it, too, if you don't really like the defaults of Node, right? So it uses JavaScript. It's easy to extend. It's very fast to implement. You can literally write a working web server with like 4 lines of code or something and start requesting to it. It's trivial, yeah?
How about jQuery?
How about jQuery? What about it?
Can you use jQuery with jQuery?
That's a good question. What do you need? What does jQuery do? So it does have Ajax in it, sure, but what's its primary function?
Let's go.
Yeah, Jesse?
To talk to the document of the web page.
It's to manipulate the DOM, right?
Yeah.
So if we no longer have a browser, do we need jQuery? We don't. So can you install jQuery? Sure. It's not going to do a whole lot for you. It'll pretty much just exist. So no, you don't need it anymore. And if you didn't like the jQuery syntax, great. It's gone. We don't use it in Node at all. I don't like the jQuery syntax. As a matter of fact, in production, I never use jQuery unless I am forced to, unless there's a gun to my head and they say, you need to use jQuery, and then I'll go, ah, and I really don't want to. That thankfully has not happened, but I've been put into some interesting predicaments with jQuery. Obviously not life-threatening. It was just, I really don't want to do that. My boss is like, well, you have to. It's terrible. Anyway. The other thing that's really powerful about Node is it has a single-threaded asynchronous model. And this is pretty powerful. It can become a drawback, but it is very, very powerful in the beginning. And what that means is it can handle multiple requests simultaneously without bottlenecking. I'll talk about this in just a moment, what that means. So, what is synchronous threading? What is these crazy words I'm spitting out right now? So, with every process on your computer that you run, a process is its own isolated container that runs code, right? It's a code execution mechanism on every OS these days. Everything has the idea of a process. So when I run my web browser or when I run a command line utility like Git, right? There's different processes for all of those. When I do git commit, it starts a process to do the commit, and then when the commit's done, it kills the process. Inside of a process, on every OS, there's this concept of a thread. And what a thread allows you to do is basically run code simultaneously, right? So a process in theory is synchronous in the sense that when you write code in that process, it executes the code in the order that it's defined, okay? So, I write a function that's just like to print to the console, hello world, right? What's going to happen when that process is executed is it's going to go in, enter the application, see that it needs to print hello world, and print it, and then it exits the application. And for the purpose of a web server, when I have a single thread, what happens is when a request comes in, the web server takes over that request and starts generating the response. But because it's synchronous and code can only happen at one time, right? There's only one path of execution. If another request comes in at the same time, what happens? It waits. It waits till the other one's done. So the other one comes through, whoop, and then the other one, the next request, after that first response comes out, can start processing. And sometimes that results in a timeout. It's a huge bottleneck. You can all pretty much assume, just by that very simple definition, that companies like Amazon, eBay, Uber, they do not use synchronous programming in their web servers, because when you have 200,000 requests a second or something insane like that, and you have synchronous processing, there's no such thing as a machine that can process it that fast. So what do? Well, we spawn threads. We take these things called threads and we say, okay, for every new request, we're going to spawn a thread up to so many threads. Theoretically, you only want one thread per core, right? Because a thread can run on a different core, and if you know anything about how computing works, you can't run two pieces of code on the same processor core at the exact same time. It's literally physically impossible. It's not totally true that there's one thread per core, but anyway, there's a certain number of threads, so they say, hey, maybe we can have 12 requests at a time, right? And they can all be processing at the same time. No one's held up. Well, automatically your throughput explodes, right? So instead of having one request at a time, now you have at least 12, and then depending on your threading model, it's possible you could have more going on with other types of execution that's a lot more complex, right? So throughput goes way up. There's a problem though, and that is writing multi-threaded code is insanely hard to do it well. And the reason is, if I have data on one thread and I start changing it, and then another thread is like, oh, I want that data too, and it starts changing it, and they start changing it on top of each other, you get these things called race conditions, where one thread's like, I expect the data to look like this, and the other thread says, I expect it to look like this, but they changed it without the other one knowing, and now it looks totally different. And guess what happens? You explode, because you didn't prepare for whatever happened, or you get bad results, or something, right? So there's these mechanisms for preventing against that, but they're hard to do. It's really hard to do well. It's very complicated when all of a sudden you have this code that now has 12 different routes all executing at the same time, and then, even worse, when you go into debug and see what's going on, your debugger's freaking out because it's executing different code every time you step through it, right? It's just going all over the place. You have no idea what the hell's going on. You're like, oh my god. It's very difficult to do well. So Node has a different approach, which is very interesting. JavaScript, I may have said this before to my class, I don't know, is single-threaded. It, at most, only has one single thread. It cannot have more. It's not built into the V8 engine at all. So, how does Node get around this? It has this very interesting model called the event model, where basically it takes in a request, right? And that code's executing. It's very synchronous. It's blocking. But then it gets to a certain part in the code where it can wait. You have these callbacks, right? We've seen callbacks in the DOM. You have on click and you get this callback. There are these callbacks in Node where when that callback starts to execute, it then says, okay, I'm done with this code. I'm going to go do my stuff somewhere else on the machine. And this code that actually handles the input of the response and sends out, or input of the request and sends out the response is free to work again. And what happens is your next request can come through. And you can keep doing it that way. And because of this event model, we have sidestepped a bunch of problems. One, we get asynchronous programming, so our throughput goes way, way up. We don't have to worry about things like race conditions because at most only one thread can be executing at a time because there only is one thread. So if something changes data, you don't need to expect something else to change the data at the same time because it's literally impossible in Node. So there's all these bad problems that come with threading that, you know, kind of take the advantage of threading and make it hard to really extract. And you still get a lot of the advantages without having to worry about those problems. Now, it's not perfect, I'll tell you that, but it's very, very powerful. So there's a whole mountain of problems that none of you will have to worry about when using Node, which is great. And you can worry about those problems when you decide to go further into your career and work on more hairy things. So this is why Node is really powerful. We get the throughput of all these better languages, or I shouldn't say better languages. We get the throughput of these more traditional languages with multi-threading without having to worry about all these problems. It's fantastic. It's a great idea. So I know what I just explained is very, very low level and very complex. Hopefully you guys kind of have an understanding. Fist 5, how do we feel about that basic understanding? Good. That's pretty good. I don't expect you to know exactly what I'm talking about yet, but you'll see it in action very soon. Anyway, Node. It's very, very powerful. I actually really enjoy working in it, despite anything I might say to the contrary. I really do. Node is extremely powerful. It's very easy to use, and with the invention of things like TypeScript and stuff like that, you can even make it more powerful. And they're even adding multi-threading in Node, not to scare you, but it's coming. So there's a lot of changes happening to make Node more robust. Anyway, let's get into coding. Let's all do something together really quick. I'm going to open up a new terminal. Everyone should open up a new terminal. It doesn't have to be Git Bash per se if you're in Windows. It just needs to be a terminal that has access to Node. And I'm going to type... I'm going to, try to expand this. I'm going to type node version. And I get a version. So the class's instructions said you should have the LTS, which is version 8.12 point something. 8.11 point something is fine. 8.10 point something is fine. If you go below that, I would update to the latest version of 8. I have version 10. But in my instructions I sent out yesterday, there's this thing called NVM. So I'm going to go ahead and use that. And I'm going to install version 8 and be on the LTS with you guys. So now if I do node version, there you go, version 8. That's why I said you should do NVM, because I installed what you were supposed to install in literally like 5 seconds. And I have the other version I was working on also installed. It's very powerful. If you want to go and install NVM, I recommend it. Get rid of your current node stuff and just use it all with NVM. It's a lot more work to get it set up, but it's worth it in the end. Anyway, that's an aside. Does anyone not have, when you type node -- version, do you get an error? Do you get node does not exist? I don't know what you're saying. Does everyone get a version 8.10 or above? Yeah, everyone's good? Okay, if you have, I guess if you have a problem, raise your hand and one of the TAs will help you. No one? We're good? Cool. That is good to hear. So let's go ahead and, let's test this while we're here. So if you're in the terminal, you know Node works, and you just type node. You get here. This is called the node REPL. You should have this little caret thing right here. REPL's like read, execute, something, loop, or whatever. Read, execute, process loop or something. Basically, you can type in node code and execute it right here in this REPL. And to test that, I can do 1 + 1, and I get a 2. That's pretty cool, right? And it's very cool. We all know about var. Hello. It says undefined. Don't worry about that. That's okay. If I type in hello, I get the string hello. Now we can start playing with all kinds of code, right? So if I want to do hello to uppercase, because I want to see what happens when I do that, I can. This is a very nifty tool, and I recommend you use it very often to test different methods. And as we get into Node and we start working with other packages, I'll show you how you can use this to actually test packages and stuff. It's very powerful having this REPL. It's like that console in Chrome, right? Very similar to that console in Chrome. Now, I will tell you, if you test stuff here in the Node REPL and expect it to work exactly the same in the Chrome console, you're mistaken. For the most part, it probably will, but there will be times where it absolutely will not, such as file operations. If I want to read a file, I can totally read a file from my operating system in Node. I cannot do that in the browser. So some things just won't work, and that's okay. But this is still a good tool for basic JavaScript functionality because it is one-to-one exactly the same as what Chrome has. So if you have Node version 8, you can expect Chrome to have pretty much all those same features in terms of just basic functionality, which is really nice. Again, it's the packages and some of the built-in stuff that you don't get. But this is still a really cool tool, so get used to it. When you're done, you hit Control-C, it says press Control-C again to exit, you hit Control-C again, and we're out. That's the Node REPL. I definitely recommend you get used to going into the Node REPL and testing stuff out. Like I said, it's going to save you a whole lot of time with simple stuff. Hey, if I do if whatever and I check this stuff, what does it do? If I want to go in here and I say, I need to check if this is an object. Well, why don't I go like this, equals obj, and then I do type of obj and see what it prints. Oh, it prints object. Oh, okay, so now I can do type of whatever equals object, and then I can do assess, right? So things like that, you can kind of clear up your understanding of problems too in JavaScript, which is really important. Any questions on the REPL?
What is the word you're calling it?
REPL, that's how it's spelled. REPL, REPL. Is REPL's how they pronounce it. REPL. Just Node REPL. If you Google that, you'll get all kinds of stuff on it.
Well, we don't need semicolons.
So in JavaScript, you don't need semicolons at all, actually.
What?
Yeah, it's pretty crazy. I recommend it. Anyone who's professional would probably recommend it because there's problems that occur when you don't have semicolons, but there's this thing called automatic semicolon injection or automatic semicolon completion or something like that, and it'll put them in there for you when you don't have them. So you don't need semicolons to make any of this JavaScript work, aside from some really rare cases where the JavaScript will not be able to compile or to interpret properly because of weird spacing and stuff, and you don't have a semicolon.
Will employers be looking for that?
It depends on their style. I can't tell you. I would say most of them, yes, will use semicolons. And any sane person will use semicolons. I don't want to be too much of like what's the word? Someone who's like, it's the end of the world, But if someone doesn't use semicolons, I'd be like, what the hell's your problem? That's just me. It's just, there's no reason not to. Especially because modern linters, there's these tools called linters too that can read your code and like make fixes for you. They can inject them for you. So it's like, if you really need to, you can check with the linter, inject them. There's no reason not to use them. Okay, so we're all feeling good about the REPL. Definitely learn how to use that. It's very, very powerful. Let's get into some code. What does Node look like? Okay, so on GitLab, I've uploaded the week 10 exercises. I forgot to tell you that. But if you want to clone them, you can. If you want us to just slack out the exercises as we do them, that'll be fine too. But anyway, the first exercise is called Hello Node. And you'll notice that on my file system, I actually have this file called hello.js. And let me blow this up. I have this file, hello.js. Okay? And it says console log hello. Wow. That looks familiar. We've all seen that before, right? Yeah. If I ask anyone in this room what that does, you should be able to tell me at this point in the course. So how do I use this? Well, if I go into the directory, O1 hello node, and I go ahead and do ls, I can see all the files in there. I have hello.js. And we have this really awesome tool called Node. Node can activate with one argument, and that's the name of the file you want to execute. And it prints hello. It's cool. I just executed some JavaScript directly from the command line. So what can I do in here? I can do all kinds of stuff. I can do var num equals 1, num plus equals 1. I can do like hello, num, whoa, whole bunch of stuff, right? can go back to my terminal. Let me just close the file system. I can go back to my terminal here, run it again, and I get hello to, whoa. Nice, that's pretty cool. What else can I do? What other data types do we know about booleans? Where bool equals true. If bool console log, yep, it's true. Oh, it is true. I cannot type J. Let's go ahead and execute again. Oh, nice. Our condition worked, right? That's pretty cool. Oh, what else can we do? Well, we have arrays, right? This one's got 1, 2, 3, 4, 5 in it. 0, I is less than r dot length, I plus plus, console.log, array value. Right, so let's see what this does. Any guesses? No, no one's gonna guess? Come on. Prints the array values in that for loop, right? So those constructs that we're already familiar with in JavaScript, we can use here now. Oh, I want to test some JavaScript I might be using. Okay, yep, question?
Well, if we have a file like some of the files that we have for JavaScript already that are pretty expensive, would that have any use doing that kind of thing in terminal? Since there's no HTML to actually compare it with?
If you're having a bunch of code that manipulates a DOM, it'll probably explode. It'll just throw an error and say, I don't know what you're trying to do. That's a great question. If you have one that doesn't manipulate the DOM at all, say it's just some functions that execute some logic, you can absolutely run them from Node. Absolutely. But if it manipulates the DOM, calls any of the DOM functions, unless you have a special library that mimics those for you, for whatever reason, then no, you'll have a problem. Yeah, Peyton?
So if you just did like variable like document, can you like pull up the document in Node?
That's a great question. Why don't we check? var d equals document. See what it does. Oh, jeez. Document is not defined. This is the kind of error I was talking about, right? So if we try to do something like document dot get element by ID, it's gonna explode and say document is, it's not a thing. There is something similar to document called global. Now, I don't recommend you get used to using it, but it's there, and it does some stuff, right? So this is the definition. If I were to console log like window or something in the console, it'd be similar to this. This is like the definition of global. There's a whole bunch of stuff associated with it. Do you need it? No, probably not, and you really shouldn't use it, but it does have some use. Window's another one. Var w equals window. What's going to happen here? I'm going to just comment this out. I don't want it to print. Oh, window's not defined. There's no window. That's fine. What else is there? There's something called process we'll get to use today. W. Process has a bunch of stuff on it too. Craziness. But you can see that Node is already different than what we're used to because certain things we're expecting aren't there. And you'll literally get an error and the application will stop if you try to use them. So it'll be a good experimentation to play with that. So what we're going to do, we're going to do our first activity. You're going to play with Node, okay? You're going to create a file called sriracha.js. And inside the file, you're pretty much going to console log the word sriracha goes great on nothing, or everything, or whatever you like to put sriracha on, and then you're going to run it with Node. And then I want you to play with it a little bit and see what you can do with Node, okay? So I'm going to go ahead and I'll slack out those. Oh, never mind. Oh, wait, those aren't the instructions. I'll slack out the instructions. Go ahead and do that. Play with this sriracha. Kind of get a feeling for what Node can do. Spend like 10 minutes doing that.
We can do something similar to this. We just like type directly into the Chrome console the code too. I mean, that kind of just executes it the same way, right?
Yeah, it's very similar at this point. But like I said, there's things that don't exist, right? So there are some differences in the idiosyncrasies.
So pretty much like anything with the document, you can't use in Node.
Nothing, no.
I tried to do like a prompt to see what would happen, and that didn't work.
No. What is it going to prompt to?
Exactly. This person, you kind of like have to write like normal JavaScript. Like if you were to try to use like a jQuery for each or something, I guess you wouldn't be able to, right? I guess I can't really think of anything else you would actually need it for besides like if you wanted to use that for each or something.
For each is also tied to arrays and semantics also. So you can use for each on an array. It doesn't have to be jQuery.
Wait, really? Oh, I thought for each was a jQuery function.
There is an each in jQuery, but there's also a dot for each on the array prototype.
Yeah, it's not on the object. You have to convert the object to an array.
It has to be the array prototype that's certified. So objects don't have to be. If you can manage to get in React Native, React is people are hiring React. Especially if you can do it now, you'll be winning. There's a lot to React other than just learning React.
Specifically for inner processing or whatever. I don't never ever try that. Like, no matter what you know. First run is not that bad. The branch is like a full run level. Each is
Oh, you're in the REPL. You can't do the It's a really good, it's a good one. Yeah, if they have access to GitHub, then yeah. If it's something you bought, then they would use it, right?
Yeah. So I should do
I do it public, and all of the code you have on your portfolio, I also do public. If you have, like, say you do a freelance thing and you charge someone for it, then you can be like, I did this for a customer, and you don't gotta give them the code then. You go, look, it's deployed and all this stuff. That's different. Alright. Fist 5, how are we feeling about this exercise? How do we feel about executing code, node code from the console? Feeling okay? Okay. Alright. Let's talk about this. We had one interesting thing come up that I think will be good to address. So I'm in here. I have this hello.js. If I go into the node REPL and try hello.js, nothing happens. If I'm in the REPL and I try to do node hello.js, it just freaks out. Why? Well, the REPL executes JavaScript code. It does not execute a script. Okay? Node itself can execute a script, but you would actually have to type raw JavaScript here into the REPL to make it work, and you can't do that by just calling the script. Now, there's a way you can still get to the code in the script, sure, but we'll go over that later. So why would you use the REPL? To test JavaScript code explicitly. Not a script, not to run a script, but to explicitly test code. Yeah, Jesse?
So you can run through samples quickly and see what you want to do.
Yeah.
Do prototyping and stuff like that.
Yeah.
That way, when you build your script, you can just cut and paste that code into your script and use it. Right.
Or if you have a condition in your script really far down, you're like, I just want to make sure this actually works. You could kind of fake it out into the REPL and see if it works. So that's definitely something that can be confusing in the beginning. Well, should we use the REPL? Should we not? Use the REPL if you want to just write some lines of code and make sure that they work real quick. But don't use the REPL to execute scripts. To execute scripts, we actually have to use Node on the terminal and type the name of the script, and it'll just do it for you. Okay. So we've console logged some stuff. We kind of got an understanding of how we can run scripts with Node. We kind of played with some stuff, right? It's pretty cool. But what else can we do? Let's just delete this code. I don't need this code. So, I was talking about some of the objects that exist in Node by default. There's one called global, and there's one called process. And if you just type process, well, not like that. If you just type process into Node and then hit a dot, certain stuff will happen, right? Oh, my IntelliSense isn't working. That's stupid. There's this process object that has a bunch of different properties. One of them is called argv. Now, if I go ahead and I console log process, and I just go ahead and run the script, process is a big old object. It has a whole bunch of stuff on it, right? But it has one property in particular that we care about right at this very moment called argv. That was clear. It's an array. Okay, we got those brackets around it. And right now it has two elements in the array. The first one is the path to the node executable on your machine. So on my machine in home carson.nvm versions node -v10.11.0/bin node, that's where the executable is. And one thing, I'm using node 10 now. Oops. Let me just switch real quick. Okay. So let's go ahead and run it again. Hello. Alright. So, similar. Same path, different version. Right? The second one is the file I just executed, which on my machine you'll note is very nested. Media, Carson, extra drive 1, trilogy, full stack, lesson plans, blah, 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 blah. But at the end you see hello.js. It's the file that I've executed. Now, what else can I do? These are the arguments that are passed into this script, right? These are command line arguments. Remember git commit, right? So you can imagine that first argument is git. Okay, it's the executable for git. The second one is commit. What's the script I'm running? I'm running the commit script. And what else can we pass into that? Maybe like a -m, right? Do a -m. What did I get? Oh man, I got a third one. This is -m. That's cool. What about a message after that? Oh, whoops. I gotta actually type a message. Hello, Mom. Oh, I got a fourth one. Hello, Mom. That's cool. So now I could theoretically build scripts that take in arguments. Well, what other kind of arguments can I pass in there? What about a number? What about 3 numbers? Notice there's really only one thing that delineates what a different argument is, and that is a space between the arguments, right? With one exception, when it's wrapped in quotes, I can have as many spaces as I want, and it counts it as one argument. Otherwise, space between the arguments represents a different argument. So this one has 5 arguments. The executable node, the script I'm executing, 1, 1, 1. And it's kind of nice because it's just an array. Well, what can we do with that array? Well, we know 2 things for sure. The first argument is the executable. The second one is the script we're running. Odds are, we're not going to need to care about those very much inside of our script, right? I don't care what the name of the script is I'm running. Maybe I do, but odds are not good that I do. So say I pass in some command line parameters. I'm already telling you that they're coming in as an array in this .argv property off this process object. What array index do I need to start at if I want to get the user inputted arguments? 2, because I need the third element, right? So what if I got 2, and I do something like process.argv3, and I type in 11. Okay, that's interesting. I did 1 and 1. Why did I get 11? Because they're both strings, right? Because when it comes in from the command line, it is a string. It does not matter what you passed it in as or what you expected it to be. It is most definitely still a string. So, okay, I got a string. Well, what if I put in something, you know, that's actually a string? Woohoo. And then I put in a 1. Okay, woohoo 1. Alright, that makes sense. Based off of what we know about string concatenation. That's true. But what if I actually want to take these arguments and assume they're numbers? Let's just say, yeah, I think it's a number. It should be a number. And I want to add them as real numbers. Well, there's a function we had to use in JavaScript in the browser to turn a string into a number. And it still exists. Would you look at that? So now if I execute this one, hey, I get 2. Nice. That's pretty rad, right? Okay. So, we have this process argv. It's pretty cool. You can do a whole lot with it. It's an array of everything that's passed into the argument. What I want you to do, I want you to work with someone, a couple people, doesn't matter, work together, try to figure this out. You're going to create a Node application with a script that takes in a bunch of arguments, and I want you to parse them properly. So maybe figure out how to convert it to a Boolean, or take a string and add 2 strings together, or 2 numbers together, but build some sort of a process up to your imagination. It totally doesn't matter. And figure out how you can parse these values properly so you could potentially use them in code. My hint for you is to start by console logging the different arguments, kind of figure out what type they are, seeing how you can check type, stuff like that, right? If you expect it to be a number, you can add it. Something along those lines. So we're going to do that for about 10 minutes. And like I said, work with someone else because this one could be tough. Okay? The primary goal of this one is if you want to check if 2 parameters are equal. I forgot to mention that. But I would also do things like trying to turn stuff into numbers, see if they're equal, something like that. So it should be an equality check somewhere to see if parameter 1, parameter 2 are the same, or something like that. Yeah, that is activity number 5. The parameter check activity.
Run something through node, I get like this throw error. Doesn't really work like there's a job, like, doing the JavaScript instead of writing, like, videos, like, or whatever. Like, but is that, if I teach,
They probably say that because there's a lot of configuration issues you can run into. They don't want to.
Yeah, I mean, I think for everything you're doing today in class, you'll probably find that you're going through some basic stuff. But you may want to look at the instructions that are typical and see if there's something in there with the install. But I think if you're trying to install version 8 and you're on 10,
except on your own computer.
I think for everything you're doing today, you're going to be fine. Are you hitting an error or something? Okay. Yeah, I think for the rest of today, you're fine. You may want to get with Daniel going forward in the class. If that version may continue to work for you. If not, you may have to either upgrade or uninstall, reinstall, just to get to the right version. But I think you're fine for today.
Can't complain. Okay, Fist 5. How do we feel about this activity? Pretty good. Pretty good. Okay. I'm going to go over it right now. Alright. So what the instructions said to do, first and foremost, is compare two arguments and see if you can determine their equality. So I'm going to show you two ways to do it, and I'm going to show you these two ways in this, the first more verbose way and the second the more terse way, because this is kind of the path you should take in your real code. You should do it more verbose, solve the problem first, and then you can refactor it to a more elegant solution. Always that's how you should do it. So first things first, we need to compare two arguments. So again, argument 0 is node, right? Argument 1 is the script, so we don't care about those. Yeah?
Is this only with RV?
Yeah. In terms of what?
Well, this whole exercise is it only revolving around RV, or do you need to use RV to do this?
We're using argv, yeah. You need argv to get the arguments out of the script. Alright, so we take argv and we start at index 2, right? Because we don't care about the script or the executable, they're never going to change. And we want to compare two input variables. So A and B are going to be 2 and 3, so the third and fourth. And then we can check if A, remember we need the triple equals. If A equals B, we can go ahead and console log true. Else, we can console log false. Right? And if I do node hello 1 1, I get true because they are the same. 1 and some gibberish, I get false. If I go ahead and do 1 and 2, I get false. If I do 1 and the string version of 1, I get true. Mother of God, what has happened? Remember, they're always strings, so that's expected. So, cool. Makes sense? Everyone on board with that? So how can we make this better? How can we cut the middleman? Well, we're really just checking if 2 equals 3, right? Do we need to assign them to variables? Or can we just plug them in and do our thing? kind of a more elegant solution if you prefer fewer lines of code, right? So let's run some of those again. Hey, true. Hey, false. Hey, false. Looks like we're getting the same results. Looks pretty good, right? Any questions on this activity? We're good? Cool. We're about to work on your first complex node activity right now. It's going to take until lunch to finish. So let me go show you the example. It is a calculator. So in here I have a solved folder. You don't have that. So in the solved folder I have calculator.js. So calculator.js allows you to do a few subcommands. So for instance, I can tell it to add 1 and 2, and I get 3. I can go ahead and add, subtract 5 and 3, and I get 2. You guys can kind of see where this is going. I can go ahead and multiply 2 and 2, and I get 4. I can divide 10 and 2, and I get 5. And lastly, remainder. I can get the remainder between two variables. So 7 divided by 3, the remainder is what? 1. So that's what you got to do. You have 5 subcommands. So this is like our first implementation of Git, but a little bit simpler, right? Just a little. It's going to take in these subcommands, and the subcommands are all going to take 2 numbers. They need to take 2 numbers, or you're going to have to do something to tell the user that they messed up. And then it's going to, based off of the subcommand, do some operation, right? Make sense? This one's going to be tough. We're going to give you about 30 minutes or so to work on it. It's activity number 6, which is calculator. So if you're going and doing it yourself through GitLab, then it's number 6. Otherwise, I just select out the instructions. So take 30 minutes. Feel free to work in a group, work with a couple people. It's totally okay. Let us know if you have any questions. We'll go over it at 11:50.
through some of them, you know, for R2, where you said, yeah, it's literally ours is pretty much exactly the same after you do that, except for like, instead of you put one, you put two extra, you know, no one. Other than that, it's before I had one of those, I feel like that should have worked too, if they should have processed R2.
I mean,
I don't know. Yeah, like I have mine like that with the operator there, but really, other than
so say you theoretically in the run you have something that made it
I think that's the whole stream thing. You gotta add that part. I would try it like when you're doing this with the like if the RB2 equals. I feel like it should though. There's like no reason why it couldn't. Wait, what? Do some, well, what did you add after the operators and everything? Let me say just undo it this time, because I want to see yours with the process without RGQ. So I just added that little one up in there, process without RGQ, so it's for save. But then I do that node count, add 1 1, and it worked.
Is that a stretch or question? Okay. Well, you were kind of this way, I wasn't sure.
Oh.
That's why we're.
so do we have to do this to
That was confusing errors.
was it process.rb?
Yes, that's how you pull the parameters. So in order to get the operation and the number, they were easily from someone grab those and
But I can add those. I feel like, I don't know why, I felt like I had to have that.
You gotta make the file sound like, looks like something.
So if I leave the command line, I can like, JS, whatever it is, add.
They're like, there's a copy you have,
Whatever they
you
are.
gotta write that in the terminal, command line.
So that thing does that for you, it's good, that's a good start. Now take that and change it.
I did the export, and then you like the whole algebra thing. I don't really know if I can get through that.
Take the command line parameter, take the first one that comes in, it's the user, right? And make it add, subtract, multiply, divide.
I honestly forgot.
Top of those,
And with the bonuses,
I got the X1 one.
the last bonus. So, other people have the same question. There's no library or no code to help you with that. You actually have to write a parse algebra. You have to pick it apart and solve it that way.
I forgot how to do it. It's like 4 divided by 10 or something, and then like.
Oh, you're trying to remember algebra.
Yeah.
Just try 2 from both sides first, divide by 4, that would be good.
Oh, okay. Okay, that's not too bad.
No, that specific expression is not that terrible.
Yeah. I haven't done like normal algebra in so long. Like, I didn't remember how it worked today.
Yeah, Adam and Jesse were starting on it, and I was like, seems like they should have a library for that. I assume it doesn't, they wrote one for it. Through the hard way.
You know, there are libraries out there in NSN that you actually have to be able to include that in that library. And your node project.
I'm not 100% convinced eval wouldn't do it for you, but there's probably some trickery
Yeah, that you
you
have
have
to
to do to make it work.
You'd have to set. You'd have to know that set.
It doesn't understand version.
It would be like, you give this eval, and then if you put X's and 8 before you equals 10, and then you're like, what the fuck was going on?
Gotcha.
So, it just freaked out. It probably evaluates
everything
You probably evaluate
around.
Yeah, because you have equal in there, it probably evaluated as a string, not as like a whatever. Probably be like, what are you telling me?
Yeah, no, I don't do it.
So if you had like 48 plus 2, you should eval that with 1. That one would probably something's wrong.
So in this case, yeah, I'm pretty sure. I only glanced at it.
The basic. I'll have to redone my first one with this one. Because I've already created the variables. The first one already passed this. So I have to redone it. Then pass.
Yeah, it was a bit more work. Alright, so, who's stuck on the first part? I want to get a command in there, and I want to be able to determine what I'm going to do with that command. Are there people who are stuck on that? I'm going to go ahead and write out a little bit of a snippet and show you. So, what we're going to do is we're going to have 3 potential user inputs for parameters, and if you do the bonus, there's one that's 2, but we'll start with the basic one. Okay? So the first parameter we need to know about is the command they want to execute. So, let's get the command out. We know it's going to be process.argv, right? And it's got to start at 2. That's going to be our command. Let's use a switch, or you can use an if-else or whatever. Right? That is not a command. Everyone see where I'm going? So, with this, it doesn't solve the whole problem for you because there's more you have to do. But what it does is it allows you to validate that the commands that are coming in are even good. Right? So you want them to match those. So that's first step. Yeah? Question? The same as an if-else. So if I had if command equals add, and then I did else if command subtract, so on and so forth. Oops. And that last one is an else. Console.log and not a command return. Right? So imagine I had an else if multiply, else if divide, else if remainder. Switch is just a more terse way to do it. Surprisingly, I don't think we ever taught the switch syntax in the class, which is really weird because it's a pretty important control flow operator. So I don't know, but you should use it instead of if else's if you're if they get really large. Break says when I hit this command, this case, I want to not go down the switch anymore. Because what it's going to do is check add. If it fails, it's going to go to subtract. If that fails, it's going to multiply, so on, so forth, right? But if it hits add and you don't have break, it'll also go to subtract. So you could stack cases.
So you would write all of your operations and stuff right above break for that particular figure, right?
Yep. Do add in here. Yep. Just like that. If I didn't have break, it'll say add or subtract. Do this right here. So you need the break unless you want them to both count as the same condition. So that's a quick overview of switch. Sorry if I confused you more by doing that. Also, return works, right? Because return is going to end the script. So return works instead of break if you need to return, but it's up to you. In this case, if I have nothing after it, break, return are synonymous. So it's your first step right there. I'll leave that code up there for you to use as an example. It may not be the best way to do it as you refactor your design, but that's okay. It will get you started. One thing that you may not think of doing either that I would recommend is first thing in the script, validate that there are at least 5 elements in the process.argv array. Right? Because you need a command and 2 input elements. If there's less than that, you're going to get an explosion somewhere, and that's a really bad error for your users. So if they give you an argv array that has 4 elements in it, something's wrong, and you can't execute the script, so it's a good idea to give them a good error message. Right? So try to fill that all in now.
actual antenna? How about the point of force or two? So what would the actual antenna be? Unless we teach them. X equals no. So I was thinking like this one process RP3 or whatever would be 4x. So I kind of figured that yeah, so if I got 0 that should just be 4, right? Yeah, the 4. Wait. Oh, I'm not supposed to have a space in there, yeah. Or the. Well, no, I only took 3 arguments. I didn't do anything with the pluses. So I think me adding those in there is messing it up. So if I just do 4x, 2, 10, I feel like that should technically, it's not really the full equation, but I feel like it should be the answer to it. Yeah, x is equals to, there we go. So I just got to put plus in there and equals somehow. We'll just ignore the plus. Yeah, so this would stay the same, 3, 0, so this is 5. Again, because 0 and 1 is nothing. 2 is algebra, 3 is the 4. So 4 is the plus, 5 would be 2, 6 would be 7. Kind of weird. Yeah, it's kind of like, so I renamed the variables for this one, because I knew like these other ones weren't really going to work up here. Didn't know if you want to use those too. Honestly, that would be hard to understand. Like, I was like, kind of managing it and piecing something together, and it's like, honestly, at the end of that, I guess I knew that, but it's just hard. It's hard to keep track of everything. And I'm naming like algebra number 1, I guess. So much to keep track of. Instead of like getting like process arguments, like also like basic basically what we're doing with this. Yeah.
You done? Nice.
Open up your command line. You like basically like console that log the process, then the first thing that's gonna pop up is I guess RZ.
Alright. Let's go over this one. Fist of 5, how'd we do? Okay, most people are pretty confident. Okay. Alright, well let's go ahead and take this example that I started working on with you. And let's try to finish it up. So, we'll worry about the extra stuff later, but let's first get it just working. Okay? So, what do we need to do? Boom, perfect. Andy, we got to take create a number 1 variable and a number 2 variable. And what are they going to equal? 3 and 4 on the argv? 3. Let's just go ahead and copy that. And change that to 4. Now we have our 2 numbers, right? So, a lot of the work is done at this stage. There's a couple of things we need to do. So, we can skip some stuff here and just do parseInt, right, if we wanted to. But, I have a question for you. Do we want to do parseInt? What if they do 1.5? Can we allow 1.5 as a number? Right? Yeah, I'd allow it. Add 1.5, 1.5, you get 3. Is there another one we can use instead of parseInt? Parsefloat. Nice. Parsefloat works exactly the same, except it allows you to have decimals. parseInt will chop them off. So now we have decimals allowed in this whole process, right? So we've got our 2 numbers, we have our commands. Let's go ahead and create a variable to store our final result in. Result equals, this one's going to be an add, num1 plus num2, right? This one is going to be num1 minus num2. This one is going to be num1 times num2. This one is going to be num1 divided by num2, which could get interesting. This one is going to be num1 what? Modulo. Modulo num2. And this one, we probably don't want anything to happen, right? So why don't we just return if we get an invalid command? If it's successful, we can console log our result. I'll show you guys the code, don't worry. But let's run through it and make sure it works. Alright, so we're in here, we have calc.js. Let's just test a bad command. Dumb. That is not a command. Okay, that's good. What about add? Add's technically a command, right? How can we make this better so I can use capital add?
You can actually put an or in the case statement.
I could do an or in the case statement, or I could just guarantee that this is too lowercase, right? Now if I did add, it should just give me a weird result. We'll get to that one. But add works with capitals. So that's good. So why don't we try add? Let's just give it a good path. We'll give it 1 and 1. 2. That looks good. 2 and 2. 4. Looking good. Getting pretty complicated now. What about 2.6? 2.897. Nice. That looks right. Yeah. Good stuff. That seems to be working. Let's just try another one for sanity. Oh my god. So divide works. But when I divide 10 by 0, I get infinity. That's not right. So how can we, again, make this code even better? Well, what if, right here, if num2 equals 0, I can console.log cannot divide by 0, not O. And then we can just return, right? Because we don't want anything else to happen. So why don't I go ahead, try that one again. Now we're starting to get into validating the user's input. One of the things with command line is it's very easy for the user to mess it up. So the reason why I'm going over this extra stuff of validating this input is so you get it in your brain that you should always expect the user to be really bad at this. And they will mess it up. So you need to prepare. Well, we already have this node up here. So how can we do this?
Yeah, process length is less than 5.
Process length
Process.rg yeah.
is less than 5. Nice. We can console.log a command and 2 number inputs are required. Right? Something nice that the user can use. So now if I do node calc.js add 21. Oh, that's not right. That's not right either. Nice. Okay. It's getting a little bit more robust. So we have the other 2 parameters. What if they're not numbers? What happens if I do parse float on an A? What do you get? Undefined? Do you know what you get?
I actually want to ask a question.
Okay.
On the validation,
Okay.
can you do that through the case switch?
This right here?
Yeah.
That's a good question. Let me finish this thought, and then I'll answer that question. So you get something back called nan. When you try to do parse float or parse in on something that's not a number, and that stands for not a number. There's actually a if. There's an is nan. And you can do an or, right? You must use numbers with the command. So let's go ahead and try it, see if this actually solves a problem. Node calc.js add a b. Sweet. Try few. Sweet. Let's make sure it works. Nice. So there's some more validation for you. Okay. So the question was, this process argv length, can this be done right here? Somewhere in this case? That's a good question. The case statement has a stipulation that if else's don't, and that is everything in these cases has to be exactly the same type. So if I do a switch on command, all my cases have to be some string. The switch is not as versatile as an if else. You can only use a switch with strings, numbers, well, really strings and numbers. If you do a Boolean, you have two cases, true or false, right? So it's pointless to do a switch. But strings and numbers are really all you can use in a switch. So no, you cannot. It will not even work. So this has to happen in a different phase. Doesn't work with the switch. It's a good thought, and it would be great if it did. And some languages have more complicated switches that do allow some things, but JavaScript unfortunately does not. Okay, well, we have a pretty robust little application here, I think. Does a lot. Are there any questions on this implementation and how it works? I'll slack out this code, and then what I'm going to do is we'll have one of the TAs slack out the given solution, which also has the bonuses. So you can look at the bonuses too. I'm not going to cover them here because it does require some rework. Any questions on this? Fist of 5 after my explanation, going through it. How are we feeling? We feeling pretty comfortable with this stuff? Feeling okay? I'm not seeing every fist of 5 or 1 or 2 or 3 or 4, right? Okay, good. Feeling pretty good. Cool. Well, I'll slack this out. If one of the TAs could slack out the supplied solution, and you can go ahead and take an hour lunch. I'll see you at 1. Streamers, I'm turning off the stream. And I'll be back at 1.